So welcome to my session. So can we start? Very good. So live coding or some rowing. Who attended the session last year or similar session by me? So what I promise you, I will code something, and there was no time for coding at all, but I answered about, I don't know, 50 questions. And I was really sad. It's like this went so wrong the last year. So this time I try to avoid questions and code more and answer some or show you some things we are doing in real world. Blog, workshops, and if you have questions, you can ask next week, XTV. Yeah, just go there. You don't have to register. It's like live streaming of question and answers for 2 years, I think, already. Some workshops in Munich, and some online workshops. And this is the only slide with content I have. What I would like to talk about is Docker and Java EE and why there's the perfect synergy. So, and sometimes like, I'm the only one who sees that because it is really perfect. And the reason why it's perfect is because Java EE, per accident, is the only technology which separates the infrastructure from the business logic. And Docker does the same. So what you can do with Java EE, but not with the others, what you mentioned, fat technologies, is with Docker, for instance, on my machine, I have Whitefly, Payara, whatever, once on my hard disk, once, regardless how big it is. And then for each thin war, there is one Docker layer, which does not consume any disk space, nothing. If you would have a fat jar, you would get one fat image for each deployment, which takes time and space. So per accident, Java EE became the most lightweight microservice technology on earth right now. Or you find something else which has deployment model. So therefore, I was a little bit involved in the microprofile discussions that you have to be careful to support still the old model with deployment, not only fat jars or fat wars, because then we are as slow and bloated as the other technologies. Yeah. So I would, about design, someone asked me so very quickly how to find microservices. In my current projects, we started with one war and React app, and this is actually for mobile. And I looked at the menu, it's like, you are crazy. It's like the first menu of the app was like 10 menu items. Like, who will click on the menu items on your mobile device? Instead of 10 menu items, we create 10 apps. And from the beginning, we delivered 10 wars, completely independent from each other, and each war had an own HTML5 client, React client. And there is one particular war, like a portal, if you will. So the user could go in, and from there, navigate direct to the apps. And because it is really hard to use menus on mobile devices. So one reason could be user experience. And now what we can do, we can ship the apps independently. We can hire different, how it's called, design agency, whatever, to skin the apps independently. And this is the benefit. And from the beginning, they are truly independent from each other. So there is no coupling between the microservices. And we are 2 developers. And we have 10 microservices. So it's just like crazy. But the idea is clear. There's 10 apps which are independent of each other. But it started with 1. OK? So whatever, if you look at the UI and you see tabs, links, whatever, this could be a first idea for microservice. Another idea is non-functional requirements. One app, we had problems with memory. And we isolated the messaging part from the business logic part. And we find, OK, now we can scale the messaging without affecting, so for debugging non-functional requirements. And if you have multiple teams, you get multiple microservices. So what it means, if you have one team, no additional requirements, you get one microservice, or however they call it, one service, and that's all. So you don't have to invent something to have 2. Agreed? You have to. No questions allowed, right? So timeouts, very briefly, I will show you how to implement timeouts. They are from the beginning. If you have nothing, the only thing you can do, or you should do, is to define transaction timeout. This is at least what you can do in Java EE, and it should be as low as possible. The default is 5 minutes. 5 minutes is crazy in microservice world. No one waits 5 minutes until something happens. So 10 seconds, 5 seconds, 2 seconds, 1 second. This should be what you should do. Back pressure was always there on application server. No one cared about this. Now we have microservices. Now it becomes popular again. So what it actually means is what happens if the pool becomes full, JMS pool, connection pool, then the clients have to wait. And this is called back pressure. So it was an initial part of application server forever. It was widely ignored by all developers and never tested. Right now, everyone is excited about the features, if I show the features. And bulkheads, I will implement them. What bulkheads mean, for each communication channel with the backend, you will implement an own thread pool, because if one server blocks, it won't take down the whole application server. This is the basic idea, and this is the idea of bulkheads as well. Very easy to implement with Java 7. It's actually built in. So what I see, people are inputting histories to Java E and downloading 50 megs of Word to have one thread pool. You get it for free with Java 7. If you like, you can still download histories, but you don't have to deploy it. So circuit breaker. So the circuit breaker already built in. You know what it is? Interceptor is one class. This is the most asked question. With a single interceptor, you get the best possible circuit breaker. I actually implemented one. I'll show you the source code, like 3 lines of code. And it will be part of Java E9, even better, so we can delete one class or 2. They are already on my GitHub. I show you, no kidding. There are 2 classes. This is the extended version. In my project, we usually implement one single class. And serverless, I watched the keynote today morning, and I think we are even serverless, if you like. So this is just, per definition, we should be able to do. So what I'm using a new setup. This is why it is in particular interesting. So I'm using the native Docker on Mac. This means this is the standard Docker setup you can download from Docker. Before this, I used Docker on Vagrant, so I had to use different IP address. Now I can use localhost. On Linux, works better, and in Windows, similar to Mac. So, okay, Docker PS, nothing runs, which is how it should be for now. So what I will do today, this is what I usually not do. I won't start any local application server. I would just use plain Maven and Docker without no hot deployment, nothing. So it's the worst possible case you will see today, without any scripts or nothing. So you have to help me, at least you, right? So you promised?
What? No.
Yeah. You will listen and watch for syntax errors. So so I'm using my own archetype, so it doesn't matter for now. But I would like to use a producer, which produces a string, and consumer, which consumes a string, and they should communicate with each other. This is the basic idea. So basic Maven project, so OK. And then I would start with a Java class, prod resource. I will try to keep the names simple in order to remember them, because in microservices you get lots of links and stuff. String prod get return 42 plus system nano time. Just current time should also work. So this is the simplest possible microservice. And now, what I'm doing, I will create here from the beginning a Docker file. So from scratch, nothing prepared. So, and I just say what I prepared is airhacks, my own images. And what I hacked in the airplane is Payara monitored. And I will show you, and this, if you get this, you will get also the idea why the synergy between Java E and Docker is so great. So I will try to explain you why it works. And the deployment is deploy target, and the name of the project is prod convention over configuration.war to deployment dir. And what it is, and this is actually how all my commercial projects at least start. So I go to terminal and prod, and what I will do is full deployment and full build. Maven install and Docker build -t is the tag name, Java 1 prod current folder. And what you see right now, it was full Maven build plus full Docker build of the full Docker image. And if you go to Docker images, you see here, this image 10 seconds ago is 750 megs big. I got a question, you are crazy. You cannot deploy that 700 megs of microservice. The truth is, it's a virtual image size. So what happens is all the images share the same application server. This is what you have to know. So what happens behind the scenes is similar what Git does. Is called Merkle tree, or what's called content addressable storage, I think, is the term. So it means the Payara resides only once on my disk. And this image is actually just, I don't know, a few kilobyte big, because my war is like 5K. And by the way, it built everything in, what was it, 1 second. It is impossible to build 700 megs in 1 second, even not on Mac, right? By the way, Macs are a lot slower than everything which comes from Intel, because it's an outdated CPU, so your experience should be a lot better. Okay, question? No questions. So forgot about this. So this was, and then I would like to show you something else. So how to connect services with. Oh, wait a second. I built another service, and I call it consumer. Consumer. And this is the same Maven projects, which the name is going to be con.war. And the consumer will communicate to the production service. So what I will go to airhacks consumer and con resource. And this is path. So now, doesn't matter. And what I like to do is to communicate with the other service. And this is where the questions start to be more interesting. And what I would like to do is to use the jersey and this client, and then and the URI should be localhost, but there is no localhost. So if I would ship it to Docker, there is no localhost, so it would never work. And I don't know the IP address. And this is where I get the question, though, do we need service registry, API gateways, whatever? The answer is no. What we do usually, I just assume the name is going to be prod, because I have no bad idea, so just name it prod. And just assume the pod number is, yes, 8181 would work. Prod, what was it? Resources prod. Right? So you, yeah. If it doesn't work, it's your fault, right? So return this client, this target. No, this I have to forgot something. And this is the prod target. And this prod target request. This is the old stuff, no tricks, get string. A little bit ugly, because if there's something error happens, I get strange errors, but should be enough. There will be no problems. It should work out of the box. So now, and what we would like to do here is the same. New Docker file. It's just text file. Usually I copy this. This time I was like, okay, I would like to create this from scratch. And this is one reason why I'm using this monitor. So, and I will copy this target. This is nice. Maven convention of a configuration con.war to deployment dir. So I go to con and say the same install. Actually, package would be sufficient. Docker build -t Java 1. I think it was Java 1 con dot. So Docker images. Now we have two images, but both rely on the same Payara monitored, so they don't consume any additional disk space. So there's a most asked question, you are crazy, you cannot create microservices with 700. It's like, this is not how Docker works. So without Docker, we would have a problem, but now everyone uses Docker more or less. I mean, there's everywhere. It's not like, okay? So now it's time to chain them together. And what Docker is able to do is to do this. So I can create a network. Docker network create Java 1. Docker network ls. Java 1 is created. It's a default local network. It could be distributed, but on my machine it's enough to have a local network. So now what I would like to do, I would like to say Docker run in background or detach mode -p, and the port was 8181, I think, and I exposed the internal port 8080. Okay, so 8080 standard Payara Glassfish port exposed as 8181. And the name of the image was J1 producer. And I would like to name it name prod. And now the cool story is, I also would like to say net J1. So launch the container in Java 1 network. Cool, it even works. Docker ps. So you see it is started. Docker network inspect Java 1. You see the first container prod is in the network. So I say, okay, cool. So do the same, a little bit different port. 8282. Let's call it consumer. And this is consumer. Usually we use a NASWorn on a scripting that we have the conventions. So it's not like if we're feeling like this, we have a small script. And yeah. And also started Docker network inspect J1. So we have producer and consumer. And now the cool part happens. What Docker does for me, it resolves the container name. It becomes the container name becomes the host name. So now I can swap in real time the implementations, and I don't need any additional registry or whatever. And if you would like to have like load balancing or whatever, what we use HA proxy. You will also see in the Docker's repository. So you can register HA proxy, which load balances between two other containers. So and this was more than enough in all my enterprise projects. Of course, for Facebook, Twitter, this is not the solution. But I'm not building Facebooks now. For now, right? Probably next year, but for now, my projects are not that exciting. Everyone agreed? Should I repeat something? So repeat is OK. So everyone crystal clear. So user-defined network. So it's just like isolation. Whatever you put to the network, they see each other. And this is actually a great idea for security. What is sometimes we have backbone network and front-end network. And there is one container which is known by both networks, like a gateway. For security reasons, it's also a nice idea. OK. Should be related. Yeah, ask question, and I will try to hack. So local out. No. Consumer resource? No, it cannot. Con. Resources. Wait a second. Docker ps. What are the ports? 82, 81. This is the con. Should work, right? This is the, let's see, Docker logs, just the Docker file. What I can do, Docker logs con. This is what we're asking, and we see here the error. And the error is unexpected end of file. So let's see what happens is prod 8282, right? Oh, prod resources prod. This looks actually good. Prod 8181 processes prod. But it cannot talk to the other service. So Docker logs. Pardon? Just look at this. So we have con 8181 and prod 80. No, wait a second. 8282, 8181. So con is 8282, 81 should work, is exposed. In such cases, You can do even this, con prot. So and now everything is gone, and I can just say run, and now watch this. Watch me. Con J1 con is 8282, right? This is the con. And the other and 8181 was prot, so it looks everything reasonable, right? So and the only thing could be the network here. So '82, '82. Where is my network?
Is there anything already running on 81, 81?
I don't think so.
Try 83, 83.
Yeah, of course. But what I would like to do is to disable this first. This was sometimes an issue. Okay, we can start with 83. And the name should be different. Just see whether it works. Localhost 8383. No, I cannot access them at all. Don't worry, it always worked. Maven install. So it should be there. I hope everything is saved. This would be terrible. So everything is saved. So we have the con, which is resource. Its path. This looks nice. This looks nice. And now now I will build it again. -t j1 con dot. Okay, build. This has nothing to do with communication between microservices. I cannot access the Docker right now, and I guess this is something to do with the network because it worked as always. Docker run -d -p. What was it? 8484. Let's say 8080 is the default port, and the name, call it the con2, and this was J1 con. So and now it should be visible 8484. So it works. The problem was the network. So it's like the wireless LAN just screw up my network, and localhost was not available. So okay, now we are sorry for that. So Docker kill everything. So what we have, con2. And what we wanted to do, we would like to launch, to run the prot. This was, what was it, 8181, port number 8080. This is the first one. I have to use different port because since I have just one machine. And this is the port mapping, -p. And the network was --net Java 1. So it binds to the Java 1 network. The name is con. And the image is con. So this is where it was built. So -name con, Java 1. Pardon? What? The port is 8181 from or RT 8282, right?
Yep.
So Docker remove con. So again, 8282. So now it works. Let's see whether I can at least access the server. 8282. 82. No. It should be in this.
Started the 8484 without the network. Without the Docker network.
No, it should be accessible from this. From localhost, it should work. Yeah, I just, maybe something is running, what I don't know. No? We can try it. So 3. H 284. No, it's not a problem. It's like, or it is very slow. Okay. So this is up right now. So let's see. We have too many microservices right now. We have the last time, and then I will take a few seconds until everything is up. So Docker kill everything. So it's con, Docker kill con 1 and con 3. And I can remove con 1 and con 3. So and now if the image is built, so I can start again. And Java 1 is the crucial part. It always works. So it has to work in the Java 1. Net Java 1, detach mode, and -p. What we start first is 8181, 8080. The name was prod. The name was prod, and the J1 prod. Docker remove prod and con, and run them. Okay, now this runs, and this one was con, and let's assume 8282 does not work, and this should be enough. So Java 1 network name con, J1 con. Okay. 8484. Okay, Docker logs con 4. So, seems to work. I just have, it's extremely slow, so I know. So obviously it waits for the network or something because it takes forever until the server starts. So in order to show you something more until it starts everything, it's like the server are too slow because they're waiting for the connection with, at the start. So what I would like to do is, I would like to show you how to configure from source code an application server from the outside. And to do this, just assume you would like to use here a prefix. And the prefix is going to be injected. And this is like a message. And say message here. And this could be any configuration you like. And what you can do, you can say, OK, I would like to create, I show it a lot, configurator. But this time, the configurator is going to access a different resource. So expose injection point IP produces. So an IP is the name of the member. So this is nothing new. What's new is what we do with that, and return system, and now get get env and say get or default, and this is the name of the property, and the default is not set. So why this? And the interesting part is, if I start a Docker, just do it again, run. If I start it again with a higher port, what I could do, I could set with -e the key value pair, and this is message, and set it to, for, I don't know, Duke. And what happens behind the scenes, it becomes the environment entry of the Docker container. And you can specify even a file with key value pairs, a full file, and with that, you can inject all the values directly to the configuration of the application server. So we actually never change the application server configuration. We always change the, or we do it from outside, from the Docker, with the environment entries of the container. So I think we have already con 4, so I will have to use con 5. So, and now Docker exec con 5. No. And you see message Duke. The cool story is you don't have to rebuild it. So this is the crucial part. This is one of the questions for staging. In staged environment, we just launched the same binary image with different external configuration. And this is very, very nice for Jenkins, for instance. With Jenkins, you can inject the configuration from outside. And this is more than enough for whatever you like, right? For configuration of whatever resources you like. So next critical question was how to deal with not Dockerized databases. So you have in your environment databases, mainframes, whatever, and then they cannot participate in the network. It's not that easy. And there is another hack. You can start the Docker and add with --add host, and you can just provide key value pair. So what we use, you can use, for instance, a name like Oracle database or Elasticsearch database. For instance, in my current project, we have just Elastic. And with --add host, depending on the stage, we provide a different IP address, which resolves to different stages. So without changing or recompiling or rebuilding the image, we can inject or we can swap the name exactly as it was with Docker container here with the network. We can do the same. We can do the same with at host, which is a nice, not hack, is a workaround if you have resources outside Docker, like databases usually, SAP, mainframes, whatever, and you need this for staging. Okay? Con 4. So wow, this was just. So both was deployed. So let's see, just Docker PS. And we have port, we have con, too many cons. But each con should be able to access the prod. And this was con 5. Let's say we have 8.1, 8.5, 8.5, I think. Let's see. 8.5, 8.5. Con, resources, con. This is okay, but I can access this, and now the C is they don't see each other because the name is wrong. I relied on con, but I use con 4, con 5, or whatever. But I can at least access the first one. So the problem is now this is not very robust because here I encoded prod. I started with prod 4 or whatever, so this does not match. So how the containers communicate with each other is exactly the same without any registry. So we use a hard-coded port, which is the internal port, not the exposed port, which is actually here the error. So this should be 8080 regardless how I expose the port. So this is done by the container. This is the error. So let's rebuild it. So so we have to go to the we are in the producer, and then we have to say install. This is full rebuild. And by the way, I'll ask question whether I use it for development. No, for development I use always local servers with hot deployment. This is just what I wanted to show you what you can do with full restart and full deployment. So Docker kill, what was it? Con is not there, and remove. Awesome. Oh, very good. So Docker run, and we have, okay, this is the message Duke, which is good, and 8585 was also good, and we call it con, and launch it. It doesn't matter, it still runs somewhere. 8686. And now is the problem 8686. Now it works. Docker logs con. And you can see, no, now it learned that back then it waited for the network. It took forever until it deploys. And we have, this is the newest one, 70 seconds ago, it was the port 8686. 8686. So this is the communication between the services. At the beginning, I was just too fast and the network was too slow, because if Glassfish starts, it tries to ping the domain, and it was not possible. So I got timeout for 2 or 3 minutes. So this is why it took so long. But this is the communication between both of the services using Docker network. What's essential here, I'm using the hard-coded container name. This is the container name. And this is the internal port, not the exposed port. So regardless on which port I'm starting the containers, they can still communicate to each other because it looks inside. So what it actually means, the containers inside the network communicate directly. They don't go through the external network. There were some questions about this. So from the browser to the container, I have to use the port. But between containers, they use the internal port. So no one can access the port 8080, just the containers in the network. OK? So I had a mistake here. I used the external port, the map port. OK, questions so far? Very good. Then, so what we had, to explain you serverless and what happens behind the scenes is, how it works is, I have a Java image here, and this is exactly this. And this Java image is actually the base of all images of all application servers. And this is the largest image and comprises the CentOS image plus Java. And what it means, it is about, I don't know, 500 megs, because it's the CentOS with JDK, OpenJDK full. One of the most asked questions, why I'm not using Alpine, how it's called, Alpine Linux. And the answer is it doesn't matter. It only sits once on my hard disk. So whether it is 100 megs larger or not, no one cares about this. And most of my clients use CentOS or SUSE or whatever. So I use whatever my client uses, but never Alpine. No of my client uses Alpine. And so this is actually the reason. And I'm just using stock Java, as you can see. And this is build once. I use Nashorn for this. And this is the Docker build Airhex Java. So why I chosen here the Payara? Because it is the most real-world example I have in my GitHub repository. Payara inherits from Java. So what it means, in case Payara changes, I don't have to rebuild the Java image again. So it always sits on the hard disk. It only has to be rebuilt in case I get new patches for CentOS or for Java. The Payara is rebuilt. It happens, I don't know, on each new release. And then from Payara, configured image inherited. So the crucial is to understand why. So this image comprises some settings which are project specific. So this is just a placeholder for any project specific settings, like connection pool settings, JMS queues, or whatever. And this usually happens in project specific Jenkins pipeline. So we have Jenkins pipelines, and whenever we find out we need more heap or whatever, it is built once and pushed to a registry or to repository. So, and is monitored, what I used here. It inherits from the first image, from the configured image, and it provides even more monitoring stuff. So what it actually means is, I chosen in my project to use monitoring, so I inherited from the monitoring, Payara monitored. Okay? So, but I could use configure or the plain one. So if I would say Airhex And I would like to use, let's use the con one. It's easier to see. So whitefly and rebuild the image. Let's do something like this. Now did it? Okay. Docker run -d -p, another port 8787, 8080, and don't forget the Java 1 network, --net Java 1, and the name is the wild con, and I think I still use the old one. As you can see, now it runs on whitefly. And it also stops here. It's the issue with the network, so it should be a lot faster. It should be, oh no, this is the first line. And what it basically means is we are almost in the serverless, what I heard in the keynote, because we can decide with one liner which server to choose. And what's the magic here? The only magic I did, this is really basic, is in the each Docker image here exposes the deployment dir. And this deployment dir here is equal to all images. So I can rely on the existence of the deployment dir. So what happens during the images built once, it happens auto-deploy behind the scenes. So you don't have to rely on auto-deploy. You could use even the curl. All application servers have RESTful deployment, and you can use REST or HTTP to deploy the wars. But auto-deploy is good enough, because if the image is done, it's done. So you get the binary images can be started, and it always works because it's Docker.
What do you configure the data sources for servers like?
Yeah, this is actually the reason why I have this exactly here. So each data source will be one line more here.
Oh, okay.
Here, as admin. So if you for instance, here are some AS admin to set up JDBC connections. I would have to copy both lines here, and I will get data source, JMSQ, whatever. And this is the reason why this configured, this is the ending configured, works, runs in the project-specific Jenkins automatically if something changes. It changes not frequently, I would once a month. And the first two layers are running usually by operations. If there's no patch for the operating system and we get new release of the application server, it runs in centrally, and then it's pushed to registry. OK, there was another question, so it will relate it. So who from here, somewhere? No questions. So what was it? 8686, I think, right? 8686. 7. Consumer, resources, consumer. It's not set because it's not injected. So I could, but this runs on actually on whitefly. So we have a whitefly communicating. We built two images. One is Glassfish, the other one is whitefly. They communicate. I have also Tommy, WebLogic, everything. So it doesn't matter actually anymore if you have Docker. And the nice story is you see how fast it is. So I built, I think, during the session because of the timeout issue, 10 times everything. Actually, I built the whole operating system plus the application server plus the war. But because of Docker layering, what actually happened, just the war was replaced. So this is actually the nice story. And with fetch jars, I would have to build 30, 40, 50 megs each time. So it would take a little bit longer, I would say, but not in 100 milliseconds. OK, so what we got here is communication between the containers. And what I could do, just take a look at the so this is the 8787 somewhere. 8787, and this was the name is whitecon. So docker kill whitecon and docker remove whitecon and run 8787, and now -e message Duke, and now it should be injected. Equals, and another problem here is J1, and this has to be removed. So let's see. Yeah, it works. So as you can see, Wi-Fi doesn't check the network is faster right now, or. Oh, sorry. Yeah, still works. Now it works everywhere. You know, regardless which port I put, there are so many microservices, it will always work. This is resiliency. So, back to what I use. What I use a lot is this. There are two proprietary settings, which I hope they will be standardized in 2.1. One is called connection timeout and read timeout, and this setting is available for all application servers. This is a Jersey example, but there's another one for REST Easy, I cannot remember. And what I usually do to support them is so I specify a Jersey dependency, but the dependency is only provided. So what it means, it is not deployed to the server. So and now I can compile it. So and what it basically means is, so there is a connection timeout if you cannot resolve the other server. So there's one error. And the read timeout if it's too slow. And the read timeout is particularly important because if you have some performance problems, the worst that can happen to you is the other application is too slow. If you cannot connect at all, is a better than it's just too slow. So milliseconds. So I just wanted to provoke some. So 10 milliseconds would be too. So what we have, timeout is built in. So this is just you have to do this manually. So I could just, this is a string. You can just add the string, and it will also work without any external dependency. So it's really up to you. So this was the timeouts. I don't like to show you that it actually works. It would work if this is too slow. Another thing you could get right now is a little bit of reactivity. And I would like to show you how to implement this. And to do this, I would implement a method called getContent and put this method here. So message getContent. And and I could rewrite it right now and say this is suspended. Async response. And what happens then, I can say response.resume. So, and what it means is it is almost asynchronous. It doesn't make any sense, but it's a little bit more asynchronous. And to make it nicer, what I could rewrite it and say, okay, there is a, or just because of time. So we have one thing which accepts strings on objects, and another thing produces strings and object. And the basic idea is to chain them together. And to save time, I just show you the end result without explaining, because I explained it multiple times. But what I would like to show you the effect on this. Completable future, the new stuff from Java 8, I could say supply async, and the supplier is the method getContent. And if this happens, then say then accept and response resume. So, and what this means is, So it is executed fully asynchronous. So the first this is called, and if this is done, it is passed here, and this won't block. The only problem is if you go to the source code, you will find out there's a fork join pool, which is a bad idea because it is depending on number of cores. And therefore, what I use usually is I say resource managed executor service, MES, and this is the standard executor service, has to be available by all Java 7 standard application servers. And now the managed executor service is just an executor service from JDK, so it's nothing special. And what I can do, I can pass it here. And now magically, we have a bulkhead. Because I can configure as many thread pools I like, and what you usually do, one thread pool per communication channel. We have one communication channel between the consumer and the producer. For each such communication, I would create a thread pool. It would be nice to have it a monitorable thread pool to see what happens and to make it configurable. And I actually wrote a very simple library called Porcupine. Why Porcupine? But because it's another name for Hystrix. And what it actually does is it creates managed threads, and you can inject it with, I'll show you, with @inject dedicated executor service. And I would like to show you in action what it actually does. So to make it work, I will add the library. It is really optional. The managed executor service is good enough. You will have to configure the application server. What the Porcupine does, you can configure it by yourself. That's the only difference. But the underlying technology is the same. Each of the libraries uses the managed threads from the application server. OK, so we got the Porcupine. And I use the SPI version for a reason. And this is CommyAX. So and the only change is, instead of doing this, I would like to inject the executor service just, and no resource, just say inject with the qualifier dedicated. And let's call it prod channel to make it nicer. So prod channel. So now it should work with that. And I have, of course, rebuilt right this. And actually, to make it more automated, I could say docker kill con, right? And docker remove con. Now nothing can happen. Almost Jenkins, right? In one line. So now everything. So 8, 7, and 7. White con. OK. Forgot the white con. But we have the con. So I forgot the white con. You see, this is docker remove kill white con. Docker.
Con means in French?
No.
You don't want to know. Yeah, exactly.
Hey, sorry for this. So just consumer, of course. My last name implies that I know French, but I don't. What I wanted to do is to run it. You just made me nervous. OK, docker run -d -p. What was 87? 87 should be free. 8080. Name con. And what was it? J1 con. And the network, yeah. -net Java 1. And the prefix doesn't matter, so I can leave it, I hope. It's already in use, docker kill con. And docker remove con. OK, seems to work. 87, 87, go here. Okay. And what you can see, you get injected statistics into the header. So you see the production channel is pipeline name production channel, rejected execution handler. And the nice story is this is the rejected execution handler from JDK. And what you get with that is back pressure, of course. So in the execution handlers from JDK, the stock execution handlers, you can specify what happens when the executor service is overloaded. Should it forget the new task? Should it block or throw exception? So you can do the same with this executor service. This is exactly the definition of back pressure. And you can see what you can do. This is the standard. In case the thread pool becomes overloaded, it can throw CDI events. So you can register for these events and expose them via WebSocket or whatever, monitoring service. And you see the maximum pool size, largest thread pool size, and current thread pool size. They are all configuration from the stock executor service. So what Porcupine does, it just uses the managed threads from the application server and wraps them as an executor service and makes them configurable with a simple builder. So with that, with 3 classes and about 5K of code, we get bulkheads fully implemented in Java EE. Okay? So you can see really all the patterns are built in. So I had a conversation with an attendee today, and they say, okay, what I'm actually doing in the project, I'm removing stuff. It's not like I'm going in, and selling you 1,000 patterns. It's like we remove whatever is not necessary. And the funny story is that Java is a perfectly suitable platform for microservices. And all errors happen right now wouldn't happen with a simple script, because then you have convention with ports or whatever. And what I do usually, I increase all the ports on a scheme with convention. It's not like wild assigning ports, so you have a certain scheme. Questions? So I think we are pretty far. I show you how to configure with one-liner system. What I didn't show you is a circuit breaker, right? The real circuit breaker. This I would like to show you. The implementation. And the full implementation is also on, I don't have the network right now. So usually, you wouldn't code something like this. In real projects, you are not allowed to put any business logic into a resource, because it's really hard to test. So what do you usually do? You have a resource just with the HTTP stuff, and you have the facade just with the business logic stuff. And the cool story is the facades get an interceptor, a standard stock interceptor. And what interceptor can do is to catch all exceptions, and it can also measure the performance. And with that, you have your circuit breaker. Because you don't have to invoke the methods. You can count the errors. You can open, close the door, whatever you like, and this was the breaker. And I was in several microservice projects, and all the question, what is about breaker? We have to build a breaker, and they dedicated already, 1 month to evaluate external libraries. And therefore, I created the 2 GitHub projects, just to show this already solved. And I would like to show you the implementation from without the network, which is breaker. And this is just 2 classes. So this is a stock interceptor. What here happens is I'm reading some annotations. Because it's configurable, but the whole implementation is 75 lines of code. And what it does is it catches exceptions. On the exception, it delegates that the exception happens to a class, to a delegate. The class is called circuit. And what it also does, it measures the performance. And it is too slow. Here it says it's timeout. And the circuit class is here. So the circuit class just gathers the information and decides whether it is open or not. Why does delegate to this class? Because you can override the class in your project. You can say specializes my circuit, and you can decide what to do, when to close when to close the circuit again, when to open it, and whether you would like to retry or not. So what we find in projects, it is really hard to find a general rule or algorithm how to deal with exceptions. In an enterprise project, you cannot say, we try after 5 minutes once if there is some, money transfer going on. It's like the other system has to be idempotent first, and then we can retry. So it is really hard to invent an algorithm, and therefore my observation was in the enterprise projects, the Hystrix algorithms were not used that often because it's really hard to tell what to happen. What we usually do, if an external server breaks, we open the circuit, and this class knows about this. We send a CDI event, and there is something like dashboard, critical exception happened. Would you like to close it or not? But it's really hard, to decide by a machine, okay, we should retry right now or later or whatever. In one project, the developer had retried, like in logarithmic scale, like in 5 seconds, 5 minutes, and 5 hours. It was never used because in enterprise environment, if it doesn't work now, it's just unlikely it will work, in 2 minutes. Okay, therefore, there's 2 classes. And general implementation of circuit breaker is one class. If you know what you are doing, it's just one interceptor. And this is so easy. There is no need to be depending on external library like this one. It's just to show you that it works. So actually, with all the timeout problems, we managed to discuss everything. So I injected the external configuration with via environment entries. I didn't show you the add host because I would have to have external database which is Dockerized. I explain you the user-defined network with Docker, and it actually always works. So, and what it means, you can rely on container names. What it also means, what I didn't show you right now, Docker inspect J1, and the command is called network. So you can see connect. All these microservices are participating in the network. But let's pick this one. What I can say is Docker network disconnect network J1 disconnect this one. Did I misspell something? Docker network J1 Docker network. Probably, wait a second, disconnect J1. So, and now it was here, and now it disappeared. So what it means, what you usually can do, you can start a lot of microservices without specifying the network and just assigning to a network dynamically. So you can swap the microservices, so you have almost like API an indirection here. Because you can, you could replace in running system Payara with Whitefly without restarting the services. They don't have to be started with the --net. You can just assign them dynamically to the network, so you can be extremely dynamic. And what is not a part of the presentation, but is very easy to do, I have an HA proxy as a Docker container with another indirection, which could dynamically, load balance across multiple microservices. This is what we actually do in production for failover reasons. So this is just the HA proxy is already in the Docklens project. So now, any questions? How do you do this across a cluster? What I'm using right now is a user-defined network, which is bridged, but there are different types of networks. They can be remote, and Docker Swarm will be clustered. But what do you mean by cluster? If I get HA proxy, it's a cluster one machine. If you would like to have multiple machines, then you use if you Docker network J1. You see, this is bridge networks, and there's different types of networks. So you can define, I think, attach. There's another type of network which is remote. So then you can spread the containers across machines. Fast.
The usage of the file system for logging, I've seen that you saw the Glassfish logging. It's logging, I guess, in the file system or to standard output. Have you used logging, make your logs external?
Yes, like a Kibana or, yeah.
So is that a best practice?
It depends on the depends on the requirements from
Because when-
operations. If no one looks at Kibana, yeah, we do nothing unless we have specific requirements.
Okay.
Because if you just tell developers log, they will log just like I was here and I was there, and this is worthless anyway. So whether you have hardly defined rules, this is great, or yeah.
So you're not, the second question is regarding orchestration. As far as I see, you're managing Docker just manually or?
Not manually. Usually it's highly automated. It's, for instance, Jenkins, curl, or whatever. But it's not like I'm not in project with hundreds of microservices.
Okay.
Even in large projects, we will get probably 20. And with load balancers, we get at most 40, 50 across multiple machines, and this is still manageable.
Okay. Without an orchestrator.
HA proxies are kind of orchestrator.
Well, I mean Kubernetes or Rancher or projects like that.
No, one project uses Rancher, but I forgot they have specific requirements. All others, we don't have such an orchestrator now.
Okay, that's good.
Yeah, but don't forget, we are moving from enterprise space to Docker. It's not like we never had something like an orchestrator before. It's not like we are moving from Twitter to.
Yeah.
This is different part of requirement. Other questions? So sorry for the timeouts, but we still managed to show you all the contents, and I hope you see how great it actually is. From the build time, we built Maven full build with Docker image in 2 seconds without any hot deployment. This was the worst possible experience you can get. Forget the timeout. So this was just out of control. But yeah. So if no questions, you can ask me after the show, and yeah, we have to go out.